Hello college algebra student, this video is for chapter 3.1 part 2 about function notation and how to evaluate a function. So let's just talk about the notation of writing a function. We say when we write a sentence that say height is a function of age, we are relating two quantity that's changing. Height is changing, age is changing, but somehow they are related. We want to relate them. So height is the output because it is related to age. So you start with age and you will get height. So whenever we talk about something is a function, that quantity is the output and of it is the input. So in a nutshell, you would think of getting a table of age. And then for each age, there is a corresponding, you must have a corresponding height, kind of like that. And you can think of it as age being the input. And if you know your age, then you know your height. I think it talks about kids, right? For adults, they are the same, but it's still a function you can have. After you hit 18, 19, you have the same height, right? Like that. So it is a mapping like this, and you call this a function. So this is the conceptual idea, and the way to write it is you say height is a function of age, of is the input, and then to write it you will say height is equal to a function of age. So we use f as the function name. F is the name of the function. And then we use a parenthesis of the input to represent the output. Now this is not multiplication. F is a name only, so it represents function of. So symbolically we would say y equal to f of x. We read it as y is a function of x. And symbolically we will y equal to f of x. It will define a function named f, read as y is a function of x, where x is the input and y is the output. X is the independent. You can choose whatever you want to do, but then y depends on x, so y is the output. So y and f of x is, you can do it interchangeably. So instead of calling this x and y, you can call this is h and this is f of h. So you would say this is x. Instead of y, you can also call it f of x if the mapping name is f. So let's look at a very simple function. This function has 2 to 3, 4 to 5, 6 to 3. So find f of 6. F of 6 means, remember, this is not multiplication, although this is a name. When in algebra we say open parenthesis is a multiplying, but when you're talking about function, this is not. So this just means that give me the output when the input is 6. So let's look at the input, 2, 4, 6. Oh, 6 is here. 6 maps to 3. So we would say f of x is equal to 3. Okay. The second question is find x so that f of x is equal to 5. So find x, find the input so that this is the output, right? The one inside the f is the input. So I don't know what the input is, so that my output is 5. So I look at the second number, 3, 5, 6. Oh, 5 is here. So its corresponding input is 4. So we'll say x is equal to 4, like that, because we have 4, 5. Because function can be represented as a graph, we can also use the graph to find function value, f of -4. So remember, the one inside the f is an input. So input is on the x and horizontal axis. Output is y is here, is f of x, right? So find f of -4 so that you would go to -1, -2, -3, -4. This is -4, but where is my point on this line? There is a point with -4 and -1 this is only point. So I would say f of -4 is equal to -1. You write the y value. This is the x and this is the y. And when you say f of something, this is x. So you write the y. F of 0 means at 0, when x is 0, what is y? So when I look at x is 0, I will say, where is my graph that has x equal to 0? This is the point x is 0, right? So you always go up or down. So in this case, I go down. For -4, when x is 0, I go up to meet the graph. At 0, it is 2. So f of 0 is equal to 2. So read it off. There's no calculation. Find x such that f of x is equal to 1. In this case, I don't know my input, but I know my y is 1. So where is y? Y is this axis. 1 is here. So where is this x? So I draw a line, look horizontally, left and right. All those points that has the same y equal to 1 would be my x. Turns out that there are 3 of them. So this is, I think, -3. X is equal to -3 because I have a -3, 1. I also had I think this is 3. 3, 1. Which one also had a comma 1 at 5, I think, right? 1, 2, 3, 4, 5, 6. Oh, no, it's 6. 1, 2, 3, right, 6. 6, 1. So all these share output equal to 1. So my x is -3, x is 3, also x is equal to 6. In a nutshell, if you want to find f of something, you look at x and then you go up and down. If you want to find x, you go to y, you look sideways, get all those points, and you look down on or up, on the x-axis. So a function can be also a formula. So which one of this formula is a function? Remember, the requirement for function is every x can only have one y. So we'll write all the y equal. So y equal to what? Is 3x plus 1. So if I plug in an x, how many y do I get? I get y. So this is what I get. So this is a function. Every time I plug in my x, I use the formula to calculate my y, and there's just 1, right? B, 6x squared plus y equal to 2. So let's solve for y. So I minus 6x squared on both sides. So y is equal to 2 minus 6x squared. So again, if I plug in my x, sometime I have 1, I have 2. Do I get multiple y? No, I only get one y. I use a formula to calculate y. So if you have a formula that is y equal to something, you're almost certain that you get a function. So it is a function. Now this is one let's look at. I have x plus y squared minus 3 equal to 0. Now y is not by itself, but it has a y squared. So I'm going to solve for y by moving this on the other side, plus 3 minus x plus 3 minus x. So y squared is equal to 3 minus x. But I want y because I want to calculate the output. Y squared is not the output. Y would be plus and minus of 3 minus x. Remember when we solve for anything out of a square, when we do this root, we have to do add plus and minus. So look at, if I plug in my x, I would always have a plus and minus. I have 2 output, right? Because whenever I have 1 x I plug in, I will have 2 output. So this is not a function. Anytime you have this situation, it's not a function. But if you have the formula y equal just one formula, that is a function. Okay, the fourth example I want to do is find f of -3 if someone give you a formula, and also find x such that f of x is equal to 2. So let's do first. For everyone, we find f of -3. So that would be, this is the input value, and I'm supposed to substitute the formula to find the output. And this is not a multiplication, remember. This, you can think of it as, this is the function, and then to find the y, I would put negative of something square plus something. X just means, this is a kind of a placeholder. If you have your input goes here, your input goes here. So my input now is -3. So I say negative 3 square plus also -3. You can think of it that way. So this is x is actually just a placeholder. Whenever that you need to find f of the output of it, you put in this input value inside. Now, order of operations say you square first. This is 9, right? So -9. Don't do negative and negative positive because you have to square this first. 9 times negative plus -3. So that is -12. Okay. And also we want to find x so that f of x is equal to 2. So that means I want to solve 2 equal to x squared, -x squared plus x. So this is f of x is this. You will place it over here. So 2 equal to that, or you would say -x squared plus x equal to 2. So how do I solve for x? You have to do by factoring. X squared plus x squared minus x plus 2 equal to 0. Solve for x. Is it solvable? Oh gosh, I think it's not factorable. So maybe you have to use the quadratic formula. So you say x is equal to 1 plus or minus b squared, 1 minus 4 times 2, so that's 8 over 2. Okay, like that. Now, but x is not so 1 minus x is like a negative number, so it's like plus and minus 7 and then I over 2. So it's not real, right? Not real. So you can solve it, but your x is not real. Usually when we look at in college algebra, our function x is always real number. So you can say there is no x that would give f of x equal to 2. No solution. The next one, f of x equal to square root of 12 plus x. I want to do f of -3 again. So that means I plug in 12 plus, whenever I see the x is a placeholder, my plus a -3. So that means square root of 9, that is equal to 3. The output is 3. And then the second thing is to find x. So that means just put f of x here. So that is equal to 2. So remember we learned how to solve this radical equation. So we square both sides to solve it. 12 plus x equal to 4. So x is equal to -8 because when I minus 12, I get -8. So when x is equal to -x, f of x is equal to 2. So this is for the second one, I can find x so that f of x is equal to 2. C. I have a g of x, I have a formula. It is, you go only have one formula, so you can find one y. I want to find f of 3 plus f of -3. So now you can cancel them. Okay, so if there's anything in a function, you can move them in and out and say, oh, this is a minus f of 3, I can cancel. No, this just means you have to plug it in 3 one time in all the x placeholder location, and also plug in -3 one time. So let's do. So what is f of 3 first? F of 3 plus f of -3. So f of 3 would be -2. 3 squared plus 3 minus 3. So this is the set. Plus f of -3 means -2, -3 squared plus -3 minus 3. Okay, so there's a lot of 3. So this would be 9 times -3 is -18. So this would be -18. And then this is plus 3 and minus 3, they cancel. Plus, what is this? This is 9. Also -18, but this will be -18 minus 3 minus 3. So it will be -18 plus 6 is -24. So you add them together. So this one is f of -3. This is f of 3. They're different. They don't cancel each other after you plug in. So 24 and 18, 42, -42, and that's the answer. Okay, so that's how you do evaluate a function by formula and evaluate a function by a graph. Okay, both of these are very important.